I've also tried to like reconcile. All right, welcome everybody to our main meeting of the Java user group. Yeah, I can't believe it's me already. Where's the year going? At least the weather's nice, I guess. So yeah, welcome. And today we have a very last minute speaker that I managed to coerce into presenting, coworker of mine. So no pressure, good Jeff. And apparently we got some folks from Amazon here too, so that's great. So yeah, he's going to be talking about his little play commercial farming operation. No? Okay. All right, great. For those of you who are new to the group, I see a couple of new faces. We meet every month, third Tuesday of every month, and have since 1995, I think. Yeah, I don't know. And I've got a bunch of other speakers lined up through the rest of the year. A bunch of really interesting talks. And if you're interested in speaking or know somebody who is, please send them my way. We love homework presentations like these. All right, so with that, let's just jump right in. As always, the thank yous. Thank you to Disney, as always. And we have some Disney people here for a change. So thank you, Disney. They've hosted us here for like 4 years now or something like that. And you know, they've been super fabulous. They're like that.
You go wrong.
I was going to make a joke about, you know, the supporter who's never around, you know. But anyways, all right. And then, as always, let's see, we got, oh yeah, Double Down Interactive, our new sponsor for the food. Hopefully everybody enjoyed. That's a little departure from our, what is it, almost 20-year tradition of pizza now. Do we have anybody from Double Down here, just out of curiosity? All right, there we go. Thank you, folks. Appreciate it.
Thank you.
And thank you, George, as always, for videotaping. George works for Dev9. That's our other sponsor, our third sponsor. All right, with that, I guess we'll, actually, before we jump right into jobs, I just want to make a quick mention for folks who want to head out for drinks. Stick around afterwards. We'll go to Sazerac, just down the street. Usually have a beer or something like that, and then go our merry ways. All right, jobs. So folks that want to talk about jobs at their companies, people looking for jobs, just out of curiosity. Oh, okay, there's a couple. Okay, cool. So people looking to hire people. Start from this side. Yes, please. So a quick sentence or two about what it is that you're looking for, your company, where they're at.
So I'm working for Amazon. I'm solution architect in the Alexa.
Perfect.
We have a couple of open positions in the US and UK, in Berlin. So feel free to come and to talk.
See, aren't you guys so glad you all showed up in person? All right, moving along this way. Yes, Double Down, our sponsor, please.
So Double Down is hiring for our platform team. We're bringing in a team of Java developers specifically. If you're not familiar with us, we're located at the International District there at the light rail stop. So if anyone has any interest in talking more about Double Down and the opportunities we have, you can see myself or Jonathan that I brought, or Jacob that I brought, that's on our platform team as well.
Okay, great. And also, if you have business cards, feel free to leave them like in the back or something for people, just so they have contact info. All right, moving along. Anybody else? Anybody else looking to hire? Oh, Trevor, of course.
Of course. Hey, I'm Trevor. I work for the platform as a online video management. We do Java. We're hiring for a number of teams right now, both contract and full-time positions, doing Java SOA stuff around video delivery. So if you're interested in video, then come talk to me.
Okay, great. Thanks, Trevor. Anybody else? All right, moving right along. So news, happenings in the world. Maybe our Alexa representatives here can talk a little bit about their technology and some of the resources that are available out there.
Yeah, absolutely. Hi, everybody. I'm Noelle Charity. I'm the one of the evangelists for the Alexa platform. You can, I don't have a card or anything, but I'm on Twitter, and anytime you look at Alexa, my picture usually pops up. But one of the things I wanted to talk to you guys about, especially those of you who are in the market to learn something new and maybe one day do something new, voice is the new normal, right? Just like cloud has been for a while. A lot of companies are just now talking to us about what voice looks like, but within the next year, that's going to go very big, very fast. And so to be able to take this information today and actually do something with it, do something actionable with it, can be critical to your career, especially if you want a career in voice development. I'm an enterprise Java developer. I actually was born and raised in IBM WebSphere. I wrote several books on the WebSphere platform, went to JBoss. I was middleware, Java, EJBs, all the way. And so now that I showed up at Alexa, I kind of have this heart for talking to every Java developer I've ever told to build any number of things over the last 20 years. So this is it. You can build Java web services that we've been building for ages. You can now build as voice, have a voice UI. It's extremely exciting. It's relatively easy. I've built about 10 skills or applications for Alexa. I've been through the certification process and failed it many times. So anyway, I wanted to introduce myself to you, certainly let you know that I'm around. If you have any questions, you can also hit me up on Twitter. I'm happy to help you if you're building a skill. But 3 things that I'll post to the meetup group. I'll post it kind of in the, I think you guys have like a way to comment, right?
Yeah.
So there's 3 different skills you can build today. One is based on trivia. Some of you might know Alexa and her trivia skills. Some may not be fans, but Jeopardy is one of our big ones. We also have things like, what do you know about unicorns? And what do you know about MLB, baseball, and hockey? And I think Kirkland Middle School alumni. Like, you can build for anything, any niche. So we have a tutorial, a step-by-step walkthrough for trivia skills, for fact skills, joke of the day, quote of the day. Anything that would be like a single piece of information where you could just be like, hey Alexa, give me journal prompts is one of my skills. Like, I like to journal and I sometimes run out of things to write about. So I'm like, Alexa, give me an idea, and she'll give me a journal prompt. It's just a random selection of strings in an array in my code. But people like it. I get about 1,000 hits a day. It's kind of ridiculous. So that's another one, fact. And then the last one is a recipe or parameterized skill. So I released something called aromatherapy, right, where I say, hey, I want something to make me feel happy. Happy is a parameter. It goes into a content library, finds out what to diffuse for happiness, and reads it back. So Alexa really opens the door for really making things super easy for people to find. In my aromatherapy mobile app, people have to go into a menu and into another menu, and here we call it infinite top-level intent. So you can bubble up any request in one call for a user. And that's really the power and uniqueness of voice. So I'm super excited that you guys are talking about it tonight. Thanks for letting me share that with you. I'll give you the 3 links. All of them are step-by-step tutorials, no programming experience is required, or more specifically, no Node.js programming experience. It helps if you know what an object is and hierarchies. But hopefully you'll have fun. Certainly hit me up on Twitter, and nice to meet you guys.
All right, thank you, Noelle.
Yes.
And since you were so nice enough to bring an architect here,
Yes.
I'm sure we're going to have all kinds of fun questions.
That's great. Lay it on him.
Actually,
Oh, be ready.
I have a couple of stickers if you have really good questions, but
Awesome.
I'm the only judge to say, yeah, this is a good question, but I have a couple of Alexa stickers too.
You better. Making sure you have them.
Thank you.
That's right.
All right, great.
Stop taking questions.
Any other questions, happenings? I just want to mention one quick thing. DockerCon is happening next month, in case people aren't aware, here in Seattle, as a matter of fact. And who hasn't heard of Docker? Just out of curiosity. Oh, okay. You should go check it out. It's really cool tech. It's very popular.
Thank you.
That was actually, there's a joke about the hype behind Docker and all that stuff. Nothing on you personally or anything like that.
Fill me in with the heart.
Oh, sure, absolutely. Any other conferences people know about locally? I know NoFluff's going to be happening at the end of the year. I think October, November, or something like that. Transnag a speaker from there. Yes, Trevor.
There's, it's not local, but Strange Loop is opening up registration June 18th, I think, or June 12th or 18th. It sells out in about 90 minutes. So, like, if you're interested in like CS nerdery, Strange Loop is the conference to go to. You know, like edge, distributed systems. You know, really, really interesting stuff. And it's in St. Louis. So if you're interested, go to thestrangeloop.org and put the registration date on your calendars.
Cool. CS nerdery. I love it. Actually, looking into some of this stuff, you'll find a lot of CS actually being used in the S20 architecture, and here will probably attest to actual use of all those computer science skills that you learn, data structure and all that fun stuff. All right, and I know there's one, I think, Apache conference happening in Vancouver, BC, if I'm not mistaken. OSCON is not happening in Portland this year for some strange reasons, down in Austin. But anyways, enough blabbing. All right, I'm going to hand the podium over to Jeff over here. And Jeff is an old member of the Seattle Java user group, actually, as you can tell. All right, Jeff, all yours.
Alrighty. Thanks all for coming. So as Nimrat hinted, this was sort of a late-breaking presentation. He asked a week ago if I might be interested in presenting on a different topic. And I said, well, I've got this personal project that I kind of like to talk about sometime. I wasn't really ready to talk about it, but the opportunity was here. So it is an alpha quality, and it is utterly personal. It's not my professional gig. So what you're going to see is totally work in progress, and I hope it's just enough to inspire you guys to take a look at some of these technologies, because I do think that they're pretty exciting. And I hadn't seen that anyone had yet spoken about them at SeaJUG. So I am Jeff Ramsdale, and I work on a solutions architect at Dev9, which is where Nimrat is also. I'm a Java developer, an electronics hobbyist, and not a particularly skilled one, but I dabble. And I am a certified AWS Solutions Architect Associate, and working on that Pro cert as well. So I have some experience with AWS. My client right now is Expedia, so I've been working there for some time and working on some cloud software, but nothing having to do with the Echo. So what is the Echo? Is there anyone who has not seen an Amazon Echo or doesn't know what it is particularly? Or well, let's start with not seen. Have you ever seen one? Has anyone not seen one in action? Okay, cool. A few people, actually a good maybe third, have never seen one used. We'll use it tonight. So just in case anyone doesn't really know what it is, it's a voice-controlled, and this is totally my definition, I made this up. A voice-controlled internet-enabled device providing a natural language interface to services you may already use. Because I think that that's key, is that there's a lot of systems out there that could use a voice interface. And here's one that's ready-made, and it's pretty easy to adapt. But you can also make your own services and provide your own user interface. It's a voice interface and with relative ease. So it has 2 speakers, 7 microphones, a Bluetooth and Wi-Fi built in, and it's less than $200. You can catch them on sale, I think, sometimes for about $150. And another part of the architecture we're going to look at involves a Raspberry Pi. Anybody not familiar with a Raspberry Pi? All right, everybody's heard of Raspberry Pi. That's cool. So it's a cheap, small computer. This is the whole computer right here. This is an older one. The new one's the same size. But it runs Linux. You get 1080p HDMI video output. It has a bunch of I/O pins. This is the newer model. It has 40 pins. Mine is, I think, has 26. The older one. The newer model is a quad-core 64-bit, and Wi-Fi and Bluetooth are built in. Mine has a Wi-Fi dongle right there. A very active community, lots of projects built on it, and it's only $35, which is a steal. Go ahead.
Truth of advertising, the bold little credit card sized computer is $35. All the stuff you need to make it useful.
It's true enough. If you want it in a box, you got to buy the box. If you want a keyboard and mouse and all that. But yeah, absolutely true. And I should mention, if anybody has any questions along the way, feel free to ask them. If they're shorter, I'll answer them right away. If they're longer, I'll punt to the end, and we'll have a little Q&A at the very end. All right, so what is IoT? And again, this is my own definitions. It's a network of everything. Anything you put on the internet, ultimately is eligible for the Internet of Things. They're often small internet-enabled devices, but also vehicles, back-end services, mobile devices, and appliances. I had the opportunity to test drive a Tesla a couple of weeks ago, and obviously that's a connected device, right? They can just send new firmware, over the air, and all of a sudden you have a new feature. When the Teslas first came out, they didn't drive themselves, but now they drive themselves. That was just a software upgrade with hardware that was obviously prepared for the inevitable future. This is an old stat from actually several years ago I ran across, but Cisco was predicting 50 billion objects by 2020 that would be on the net and connected. And it's a big data opportunity. So if anybody is in big data, that you're going to have billions of devices producing data at rapid rates, then there's lots of things that you can do with that data.
Security opportunity as well.
Security opportunities as well. Speaking of the echo, and it's resilient to network interruptions. So part of the design of IoT is that you know that your devices are going to come and go, and they should be resilient to that. So the use case we're going to look at here is seed starts. So when I first bought my house, I spent all the money on the house and a kitchen remodel, and I didn't have any money to spend on plants. But I'd always wanted to garden. The one thing that we had money to do, we thought, is we had a window box on our porch. So my wife and I went to one of the Swanson's. We went to Swanson's, and we got plants for our window box, and we spent $40 to fill a window box like this size. And I was thinking, like, what the heck? How am I going to fill a whole yard with plants when it cost me $40 to fill a window box? And I thought, well, the only way that I can do it cost effectively is if I start seeds. And so I made a little investment. I built this, I don't have a basement under my house, I have a crawl space, and somebody had dug it out before me, so it was tall enough for me to stand in one corner. So I hung this table from the joists with the chains, and I put some fluorescent lights there on some pulleys so I can raise and lower them as the plants grow. And I put a little watering system there so that I could start seeds. And so I do vegetable starts mostly, but some flowers as well. And it's kind of a pain to go down there and see if the system has run out of water. So really the whole motivation behind this is I was too lazy to walk down the stairs and go see if the tub was out of water and my seeds were going to die. Because I pretty much every year have had some of them die because some week they've started to pull the water fast enough that the mats dry out. So I'll explain what it does here. There's a rain gutter here, and there's a tub down below, which you can see better in that picture. And the tub I fill with water from a hose. And then there's a pump that pumps it into the rain gutter. And then there's overflow drains to send it back into the tub. And then over here, there's capillary mats that pull the water from the rain gutter up underneath the seeds. And then there's a layer over top that prevents the roots from growing into the mats. And then there's a layer underneath to keep the water from getting onto the wood. And then I also have some heater mats because I can raise the temperature by about 10 degrees and get things to start a little bit easier in the early part of the season when it's still a bit chilly down there. And then, as I said, I can raise and lower the lights. So I'll put the domes on early when they're just little baby seeds, keep the moisture in there, put the lights right on top of them. And then once they sprout, then I'll pull the lights up and I'll take the tops off. So that's the project. That's what we're going to look at. The sensor values that I wanted to capture were the ambient temperature and humidity, the seedbed temperature and humidity, because I wanted to see, well, how much more humid is it where the seeds are with the mat, and how much hotter is it with the heat generated from the mat. And then whether the light is on and off. There's a simple timer. It's not connected to the Raspberry Pi. It's just an old school timer that it turns the lights on for 16 hours a day. And then water depth. And the top ones are all just for jollies, right? The only one I cared about was the water depth. I wanted to know if it was low or not. I ended up settling on an ultrasonic sensor, so that's what you're seeing all the way on the other side. I didn't bring it with me because it's bolted to the side of the tub, but it has an emitter and a receiver there so that it can send ultrasonic pulses, bounce them off the surface of the water, and then detect how long it takes for them to return. And then that measurement then is evaluated by the Pi, and we'll go into what happens with all those values here in a little bit. The humidity and temperature are handled by, you see a little white sensor on the string. So this is the ambient air temperature sensor, and this is the one that was supposed to be on the seed beds. I got lazy this year and never actually got it all the way down there, so it was just dangling, because again, the important thing is the water level, right? But I do have two different sensors, and the one sensor gives you both temperature and humidity. the data gets published up to Adafruit.io. So Adafruit is a company in New York City that manufactures microcontrollers and all sorts of other little electronics devices and LEDs and things. And they've got a fantastic website, lots of stuff in their store, but even better, they have hundreds of articles about how to use them. They've written libraries for Arduinos. Is there anybody who doesn't know what an Arduino is? Because I'm going to talk about it more later. Okay, we got only a couple. So an Arduino is an inexpensive little microcontroller that an Italian, I think, nonprofit came up with. That was one of the first devices to really be cheap and easy for people to use to develop little electronics, things with sensors or robots and such. And I think they really inspired a whole industry of hobbyists and devices to kind of serve them. And the prices just continued to plummet on all these devices, and the power has gone up. And I'm going to show you some examples later on a bunch of different devices that you can purchase. Yeah,
Are you going to talk in a little bit more detail about what Adafruit.io is?
Yeah, for sure, absolutely. So anyway, one of the features that they provide is that they're kind of on board with this IoT thing. And so they're enabling, since they sell microcontrollers that can generate data, they provide a really easy to use API for consuming IoT data. So now you go to Adafruit, you buy your microcontroller, you get it home, you get it on the network, you need somewhere to publish your data to, and they conveniently provide this API. So you can go to Adafruit.io and create a free account, and you can set up feeds. So the feeds that I have here are for each of the different devices that I have, and they publish their values, and you can see when I did the screen capture of this, it had been 7 or 8 minutes since they had last had their values published. You can then make a dashboard, and this is really why I used it, because there are other places that you can send your IoT data, including Amazon, and I'm going to talk about that later. But the feature that Amazon doesn't have that I really wanted in this case was I wanted a nice dashboard. And I think these guys make a really nice one. Water temperature is another one that I never got the sensor installed for that because it had a more complicated interface. And I didn't particularly need it. It was just sort of a nice to have. But I had already built my dashboard and it was nice and symmetrical, so I didn't take it out. But here you see water depth, air humidity, and air temperature. And then this is the charted water depth is on that side, but here's the latest value is on this one. And really that's what I wanted to know right away. And if you recall, this presentation is about the Amazon Echo, and so far we haven't actually seen that, right? So we'll talk about that here. The Raspberry Pi is involved with capturing the data. So actually, let's do this real quick. It's a little bit dark here, but I hope you can see that I have these sensors. So here's the temperature and humidity sensor. Here's the light sensor. Over here is the output for the ultrasonic one that's not here. And then this is the connection for the other. This is what these guys look like, the temperature and humidity sensors. And then this is a little prototyping board. And they make these things called cobblers. Right, that's what this thing is, that plugs into the prototyping board that connects up with this ribbon cable inside the Raspberry Pi there. It goes inside. And most of the cases that you can buy, and they're pretty cheap, they're less than $10 to buy Raspberry Pi cases, most of them have the little slit in the side so that the ribbon cable can come out. Because this is a pretty common use case to do exactly this kind of thing. I bought these sensors because I wanted to kind of check it out and see how it went. There's a company called DX Seoul. It's a website that ships from China. And I wanted to kind of compare and see some of the items that they had. But I'm a big fan of Adafruit, like I said, so you always have other options. Most of the stuff where the quality really matters for me is with the microcontrollers. I'm a big fan of Adafruit, but some of the sensors and things I might consider an alternative supplier. So I'll have links at the end, and I can show you where you can get these things if you want. So back to the architecture. So the Raspberry Pi and the sensors publish the data to the feeds, and the dashboard is obviously fed by the feeds. And then the Echo, when you ask it, will tell you the values from the feeds. we will do that in a moment. There was one other thing I was going to say here. Oh yeah, I was going to explain the way that I get the sensor values is with a small Python program. And the reason why I use Python is there's better support for accessing all of the little I/O ports and features. It's still kind of hard to do that with Java. And there's a lot of libraries that are available in Python or other languages that are C-based. And I did look into the various options with Java, and it just ended up being more work than I think was necessary. Writing it in Python was just simpler. But I am a Java guy, and I prefer it. So when it came time to do the Lambda, and I'm much more comfortable in it, so when it came time to do the Lambda, I chose to do that in Java, which makes me eligible for speaking at Seattle Java Users Group. So in order to ask the Echo something, it has a trigger word. So you have to speak to it by name, although I think it may also answer to the name Amazon if you configure it. I understand a lot of people have complained about you not being able to configure the name to wake it, but I understand probably why it is the way that it is, given the number of times that we're speaking in our dining room or kitchen about something completely unrelated, and she wakes up. Everybody calls it a she, by the way, so you'll understand it. And she'll start saying something to us, and we're like, why did she even say that? So her name is Alexa, and when you say it, she'll notice. So Alexa, open crawl space. Alexa, open crawl space.
Welcome to the Ramsdale crawl space seed starting sensor application. You can ask for the most recent values of various sensors. For instance, say, what's the water level? Or you can get sensor names by saying, list sensors.
List sensors.
The available sensors are water temperature, water level, air temperature, air humidity level, seed temperature, seed humidity level, and light status.
So I'll mention a couple things. One is there's a pretty long delay at the very beginning. And that's because behind the scenes, there is an AWS Lambda program running in Amazon's cloud. Is there anyone who's not heard of Lambda? Okay, so this is a feature that I believe Amazon announced in reInvent 2014, which lets you write programs and deploy them directly to the cloud and not have to manage an EC2 instance. You don't have to have a server that you own. And you just deploy the code out there, and there's various ways to trigger Lambdas to run. But they auto-scale according to demand, and then they shut themselves down when they're not being used, and that's what we're experiencing. Because I haven't used it in a while, and I'm the only user of this program, so we had to wait for the VM that runs it to start up in the cloud. So if I'm using it actively, it'll stay up, and you won't have that initial delay. But that's what you're going to notice sometimes here if I don't keep interacting with it. If you had an Amazon Echo app that a lot of people were using, it would never shut down like that, so you would never have that delay.
What's the timeout, or is that configurable? Like how long that?
Would you like to answer that question, Sebastian?
We don't document the actual value of the timer because it might change over time. So it depends on many different factors. Roughly today, you can expect your container to be shut down after 1 or 2 minutes of absence of activity, lack of activity. But don't rely on that to do anything smart with that value because it might change.
Sure. Thanks.
The other thing you'll notice is there was a delay in the middle where I was saying, be patient, wait. And the reason for that is that the way that the Echo is designed, it will prompt you, and then it'll wait for you to respond. And then if you don't say anything, then it has a reprompt. So normally you want to have a pretty short initial spoken segment. I don't know if there's a special name for that, but whatever the first part is. And then, what's that?
An intent.
An intent? Well, no, when she speaks to me, the first little piece. Yeah, I don't know either. So you want that to be relatively short, because otherwise you're waiting. Like we're polite people, right? We don't want to interrupt. So we want to wait for her to say her piece, so then we can give her command. So if you keep the first one short, And then if they don't say anything, well, then you re-prompt them with something that's longer that has more detail, and it says, here's all the different things that you can do. So that's, you'll kind of learn some of the ways that they design the system for you to interact with it. So let's try some others. So let me just talk about a couple things here. There's an idea of a session when you first initiate a skill. And you can use the session. Session can do a lot of things. Let me explain something first of all. This is a really minimal app that I've done. So I'm going to share some information about what I've read about. I haven't actually coded it, so I'm happy to talk about it. Some of the details might not be entirely correct, but so ask any questions that you want. I might pass them along. But I'm going to speak as if I understand it. And then we'll show you code, and we'll see where it breaks down. But when you initiate an app, you open it, and it starts a session. I don't really use the session other than she stays active long enough, and if I talk with her, she'll keep it going, and then she'll shut down. But you can actually page through content. If you have something where she's speaking to you, she'll say, like if you ask her a list of, I don't know, cities in Europe, maybe she can tell you that, right? And she'll list 5 or 10 or something, and then she'll say, would you like to hear more? And you can say yes or no. Well, there's a session object that keeps that information so that she knows where you are in this interaction. And there's some other pieces of information that can be kept in that context. I don't particularly use that. There's not really a lot of context in what I'm doing. I ask a question, she answers. But you have a great deal of capability in the device and in the API. So I went to reInvent last year, and I saw a session that Capital One put on that was, I thought, pretty good. So they're trying to build a voice app. I think they've released it now. They were releasing a voice app, and they were speaking about it there at the conference, where they're trying to figure out how people would want to interact when they're talking about their financial accounts. So if you say, tell me what my account balance is, well, what's the context? We have ways of figuring things out verbally when we're talking with someone, and so we might have information that the echo doesn't have. So then she'll prompt you and say, well, are you talking about your checking account, or are you talking about your savings account, or are you talking about your credit card? And then you answer, well, I'm talking about my credit card. And then she'll tell you what the balance is, and then you can say, when is my bill due? And she knows now you're talking about credit card, and so that information is available. So there's a great deal of power in that, but you have to really think about the tree of how someone is going to walk through it and what's the context at any one point. So that presentation kind of really enlightened me into some of the problems and how you do a well-designed voice app. I didn't use any of that because I just needed to know the water depth. So Alexa, ask crawl space, what's the water depth?
There was a problem with the requested skills response.
Uh-oh. I wonder if I updated the code and broke it. Alexa, ask crawl space, what's the water level? Oh, she shut down. Alexa, ask crawl space, what's the air temperature?
The crawl space's air temperature is 73.0 degrees Fahrenheit.
Oh, it could be because I don't have the water level on here. Now, I thought that it would go and get the last value, which would have been from this morning when I unplugged it and put it to work. So I don't know. Maybe we can find it in the logs. Here's another feature. Alexa, ask crawl space. What's the water temperature? Alexa, ask crawl space. What's the water temperature?
There was a problem with the requested skills response.
All right, we'll look at the logs and we'll see what was happening. One thing that I noticed is it's actually having a harder time hearing me in here than it does in my house, and I'm kind of curious about that because when she was over here talking, she said Alexa several times, and every time I looked over here, like it's sort of natural. When you hear somebody say it, you're like, she's going to try to talk now, isn't she? And interrupt you. But it didn't speak up any time, and I was actually a little surprised by that. Because we have conversations in the room, we have music playing, and it's really pretty remarkable how often she'll pick up on stuff and start talking.
Yeah, I think it might be because you're wearing a microphone.
Yeah, I was wondering about that.
It's getting the echo. The thing is, it's doing like a Fourier transform behind the scenes to knock out background noise.
Yeah.
The echo maybe most of
That I was expecting as much, or the white noise generator, one or the other. Yeah. Yeah. Would you like to introduce yourself?
Oh, sure. I'm Eric. I work for Disney upstairs, but in my free time I do development for Alexa. I have like 3 published skills and a couple more on the way.
Awesome, great.
I have a tab with me as well, so if you guys want to play
Yeah, that'd be cool.
with this after we're done, you guys can do that.
Did I see another hand?
Yeah, I was going to ask actually. So I noticed you said Alexa ask crawl space. So is that like a? Oh, there you go. See, it was from there.
Sensor application.
So is that like a subdomain, sort of like?
Alexa, stop. Go ahead.
So is that like a subdomain, like a sub keyword, so to speak, activation keyword? Something
Yeah,
like
yeah, you have a skill.
Okay.
So, and that's a good question because there are some native features that are built in, right? So you don't have to activate everything with a skill if it's already supported by the platform. So Alexa, play Let It Be by the Beatles. Alexa, play Let It Be by the Beatles.
Let It Be by the Beatles from Jeff's Music Library.
So I didn't have to give it context, or give it an app to identify. Alexa, stop. While we're on that subject, complete change here. I'm giving sort of a general echo, kind of a overview here as well. Oh, look at that. I got locked out of my Alexa app, so give me a second, I gotta sign back in.
Children find the music search capability fantastic as well because they can ask for all sorts of random pieces of music.
Yeah, actually, I was going to ask if other folks had Echo. Who has an Echo at home? Oh my, that's a good number. So while I'm logging in here and pausing, I'm trying to collect myself. Does anybody have a story they want to say about?
Yeah, don't get me started on how many times I've
Oh, okay, 1 story per person, tops.
I was going to say, don't get me started on how many times I've heard Kitty Perry's roar.
The worst.
I would say if you're married and you have an Alexa, be very careful with the to-do list.
Yeah. There's a to-do list, so you can add things to the to-do list and they can build up quickly.
My friends have made a habit of, when they come to my house, trying to get my Echo to order things on Amazon.
Right, because Amazon does want to make it easy for you. So I just want to show you this here real quick. So they have cards. Wait, is that backwards? Can I change that with photo booth? I might not have. I didn't realize it was.
You show effects.
Use QuickTime instead.
Yeah, all right, maybe.
The show effects, I think you might be able to do it with an app.
I thought that just gave it a little over.
Yeah, that's cool. Go back.
Uh-huh.
Is there a, the mirror do this? We have mirror. All right. Yeah, it only
Wait.
takes one.
Yeah, my daughter loves that one. Oh well, you can see what it is. So yeah, Alexa, tell us a joke.
What do you feed an invisible cat? Evaporated milk.
So you can see it has tell us a joke on here if you can read backwards. Alexa, add bananas to the shopping list.
I added bananas to your shopping list.
I expect that to show up here, but. All right, well, so then you can go over here, and this is actually the feature that we use the most. So bananas is backwards there at the top. I warned my wife this morning. I said, I'm going to take the Echo, sorry if that's an inconvenience. And of course, it was inevitable that sometime before I left, she was going to try to add, rice vinegar to the shopping list, and it's like, it's not answering. You get really used to having it there, and then it's not. So, and it's got a lot of neat little features built in. It's supposed to integrate with my Nest. I'm not really sure how to make that work. I haven't found a good article on it, but it's been a little wiggy. But you're supposed to be able to, set your temperature higher or lower. Actually, the thing I wanted to know is, what is the temperature in the room? I never did find a way to get that information from it, so I think that might still be in progress.
It doesn't work with Nest.
What's that?
It doesn't work with Nest.
No, they added the feature. Like it's officially.
Nest can do that, but Echo cannot. pull that data out.
They don't
of the
provide it?
API.
Okay.
Okay.
Yeah, because I mean, for a long time, people were integrating with the Nest with IFTTT because there was no official integration, but they recently released the integration. So
That integration is really cool, by the way, to use IFT.
yeah. I mean, you can integrate with all sorts of stuff that doesn't have any direct support. I haven't exported it in any detail, but there's an awful lot of options there. Did anyone else have a story they want to tell before we move on?
It's the first time that lights, like the connected lights, are actually useful in my house now. I don't have to dig out an app, unlock it, navigate through a few menus, and turn something on and off. I just yell from wherever in the house, turn off the boys' bedroom lights,
Yeah.
and it's done.
Yeah.
Actually, that's the coolest feature of the device, is that it's always there and on.
Yeah. That's what the FBI thinks too. All right, so this is the part I approach with some trepidation. I'm going to show you my code. So, because this is really rudimentary, like there are things that don't work. I've tried to make a card so that it would show up on the Alexa app, and for whatever reason I was getting errors with that, and I haven't looked at it again because I spent all the time making the slides this week. I was actually hoping to code and like polish it up, but no time for that. So this is the unpolished bit. So this is crawl space speechlet. I'm going to jump around a bit. I hope you're okay with seeing the code in jumping around way, not a linear way. So there are a number of interfaces here. Let me move over so you can see that. So this little, I don't know if you're Eclipse people, but this means that it's an interface. So there's on launch. So remember what happened when we launched? It said, welcome to the Ramsdale crawl space seed starting sensor application, and then here's your lead prompt. And then I wrote a little utility method that I can show you for how you create an ask response. Well, I should have looked all this up to remind myself because it's been a while since I looked at it, but I think that's when when she's asking you a question and then waiting for you to answer. So that's on launch. And then you can do session started and session ended, but I didn't need those features, so I just logged that those events happened. And then let's talk about intents. Actually, you know what I'm going to do? I'm going to go back and I'm going to look at, I'm going to show you the intents, because I think that's the best place to start. You have to create these text, this text content. I have them as text files here so that I can keep them in sync with my code. But I'll show you how you actually have to go into your configuration in the Alexa dashboard. And you have to paste in this metadata on what your syntax is going to be. What is the language that it's going to understand? So we'll start with these. Your intents have names here. The first word is the token. That's the name of your intent. And then after that is the text that will trigger that intent. So if I say, I'm going to zoom in, sorry. What's the air humidity? It's going to go to the air humidity intent. And I probably could parameterize this so that I didn't have to have a separate intent for all of these, because there's some repetition in what is the air humidity and what's the temperature of the air, and I could make those variables, and I'll show you what those look like down the line. They do recommend that you put in as many different variants as you can think of, because that will help the Echo figure out which intent is supposed to map to the text that you say, the words that you say. So there's a lot of different ways to say things, and some more than others. So are the lights off? Are the lights off downstairs? Are the lights off in the crawl space? And and then what is the light status? And you can do some trickery because then you're actually going to answer that question in different ways. If I were to ask you, are the lights on or off? On. They're on. But if I say, what is the light status? I mean, that's a little unclear. I mean, but you could. But one is a yes or no question, and the other is an on or off question, right? But I can map them to the same thing, and then I can have her answer be explicit in a way that you're comfortable with her answering that way, regardless of which of those questions you ask. And so you can be kind of clever about how you ask or how you answer and which things you support. There's some experimentation involved in that. Here's the list sensors intent that we used as the first command. And then here at the very end, what's the value of sensor? So here, oh no, this isn't the very end. It's kind of a little wavy here with my scrolling. All right, there we go. So here's a variable, and we can, I forget the term they use for this, I'll show you. The sensor is going to be a parameter then that's provided to my code. So we'll go back to our code here. Now that we know what the possible intents are. So now I just have a simple case statement with all those intents. And I parameterize this get sensor response just to save the code. There's also some boilerplate or kind of out of the box support for cancel, help, stop. There's actually been a few more I think that have been added recently. But if you say like shut up or stop or goodbye, maybe, I'm not sure what else, but there are things that you can do. Help, then you can map that to an intent that will bring back some behavior. Constantine.
So there was lots of repetition. What is what? Is it possible to define the array somehow? And prefix is that.
Yeah, I mean, I would like to. I should spend some more time looking at other people's code. When I first started writing this, like I just looked at a couple of examples and then hacked out enough to make it work for me because I had a pretty limited set of features that I needed. But so, I mean, I would love to know. I'll show you my other one, my other program later, where I have a problem that I haven't figured out how to make it work, and so maybe that'll be a question that I'll ask you. But if you want to speak to it, feel free.
There is nothing from us yet, from Amazon at least, but I found a project on GitHub last week that is doing that. You give one or two sentences and it generates a lot of combination of that. So it kind of generates the intent list.
I think I've seen that same one actually, yeah.
There are a bunch of those, but also you are a bit aggressive. Like you don't, having done considerable testing, you don't actually need to get apostrophe S, all that. I don't know what it is. It'll do contractions just fine.
You know, I actually was curious about that. I mean, specifically about contractions, but I found something in the documentation that had contractions listed, so I did it that way. But I believed that it would probably figure it out because it figures out some of the other things that we say.
The platform's got a lot better over the last several months in terms of what it will pick up.
Yeah, that doesn't surprise me at all. Okay, so let's see here.
Question.
Yeah.
Is there a notion of restricting intent to certain users? Because I assume that there are multiple users in the house, and like in the example you were talking about the banking application where you don't want to have kids start accessing that. Is there a model like that?
Yeah. So as far as I know, the Echo doesn't have any support for identifying speakers. So and if there were a way to identify yourself, like I have an Xbox, and you can flip your buttons or whatever to like log in, and nobody can really see what you're doing. But if they said, well, who are you? How, identify yourself. Give me your password, and you're like, 3, 4, 5, 9, whatever. It obviously would work, right? Because everybody would hear it. So the only way that I can think of that would work is either you somehow do something with the Alexa app on your phone to say, like, within some short period of time, it's you, yes, I really want to order this thing or play this explicit lyric song or whatever, or they need to add support for identifying the speaker with some sort of recognition, which would not surprise me that would be coming, but I have not heard any rumors to that effect.
We have some very frequent customer questions and very frequent customer requests as well. There are two different things there. It's to recognize that it's a different person talking, like my kids or my wife, so the same person. The next step is to actually identify that person and to know it's my wife, and not just to know that it's not me. So we are working on that. Stay tuned for future update to the platform later. The way Capital One is solving that problem right now is to ask for a PIN code. So if you want to do a payment, for example, if you want to move money from outside of your bank account to someone else, it will ask your confirmation and ask your PIN code. But as Jeff said, you have to say the PIN code You have to talk the pin code so anyone in the room can hear it. And that's a kind of compromise we have right now.
Did you say pin code?
A pin code.
Pin code.
Pin. With 4 numbers, 1, 2, 3, 4.
So let me show you this on the intent. You get this intent request, and you get your session object that I was mentioning that can maintain like your paging and things like that. And then I have this method for get intent name. So given an intent, you have to go and get the name, and then I don't remember why this is actually, but oh, I see, because I have to figure out which of these it is. So here's a sensor. So this slot, that's what it's called, slot. So the variable that we saw for the word sensor is called a slot, and you want to be able to look that up and then find which intent that goes to. So if they say water level, if they say water temperature, then I need to map those to the water level intent and the water temperature intent. Because in that case, the echo is not able to do it for me. The ones that are very explicit, I can directly return the intent. The ones that have the slot populated, I have to figure that out myself. Let me see what else we're doing here. Okay, so here's where I'm doing my get feed info. So get a sensor response. So given a feed ID and a sensor name, I'm going to the Adafruit REST API. So I realize now that I didn't show you the Python program first, which maybe I could do. You want to see that real quick, and we'll come back to this? Let's do that. Because that makes more sense. We don't have any data yet, so how can we see it? Okay, this is my rudimentary Python. I'm not going to show you my AIO key up there. So all it's doing is just a series of requests to get data. So it's checking is light on, which I'll show you down below, and then logging it. I'm writing into syslog just because I could. And then I can run it from the command line to try it out and see the results, but it's also publishing the values. See the AIO client right here? Send. So that's where it's sending the data up to that feed. And one thing I never figured out is why do all my feeds have a -1 at the end, but I use names without the -1s. I could never figure out why that is, but that's what happened when I published the data. So I would create a feed called crawl light status or crawl water depth, and then I would publish the data to it, and it would get published to a different feed that it would create because it didn't already exist with crawl light status 1 and crawl water depth 1. So that's just a peculiarity of the Adafruit I/O. So it sends each of these values. There's the water depth, which, oh, this version doesn't have it commented out. The one on the Pi, I had to comment it out because I don't have a sensor there and it was locking up. We get air temp and humidity, and I do a calculation to convert, I think, this is just formatting. The water depth, I had to do a conversion, and here's a secret failure of my code is it actually is returning how empty it is, not how full it is. So I never bothered to switch it because I could switch it in my mind and I knew what it meant. So 30% means it's 30% empty, not 30% full. But I probably should switch that if I
Depends on if you're a pessimist.
yeah, I suppose so. And here's your ping distance. Sorry, somebody asked me a question?
Are you an optimist?
Yeah, exactly.
So is this is the desktop side on these functions?
What's that?
This is the desktop side?
So this is the Raspberry Pi. So this is the device that's actually in the crawl space. And I don't know if you could see it, but I thought this was worth seeing. There are actual cobwebs there. It's kind of hard to focus on them, but I did, just so that you know, it's really was in my crawl space. You can come look at it closely afterwards. And let's see, was there anything else we needed to see here? No, but so I'm using libraries from Adafruit or other people to read some of these values. So at the bottom here you can see Adafruit EHT, so this little sensor with the temperature and humidity called a DHT22, I think. Question?
What's the interval on this?
Oh yeah. Did I tell you that I did this with a cron job?
No.
Oh, I meant to do that. So I just set it with a cron job for every 10 minutes. You can do however much you want, but I didn't think I needed resolution any higher than that because my water doesn't run out that fast. But it makes a better looking chart than if you do like, hours. So, so that's why. Oh, and I actually didn't show you the live chart, I don't think. So let's do that because it's kind of interesting. And the reason is because I unplugged my Pi all day, and so there weren't any values published for a long time, right? So it stopped publishing values this morning when I unplugged it to go to work, and then I plugged it back in and got on the network here, and so the next data point was hours later. And then if you look at the water depth, that one never changed, and the time there is still from 9 o'clock something this morning, and all the others have been, updated to the most recent time. So it's every 10 minutes it's currently publishing data. I actually thought we might play with that. Let's, what time is it?
Excuse me?
Mm-hmm.
And the code here to proactively alert you to the water.
Yes, no, that's a really good question. Somebody would have to do that, right? And so somebody would have to monitor it, and I have to run that program somewhere. And I could, but this particular architecture isn't really as well suited to that. Because Adafruit, I don't think the Adafruit API has that. Actually, you know what? I think it does. I think the Adafruit does. But I had always sort of imagined doing that feature with the Amazon IoT with the support, which is much more sophisticated. And I'll show you a little bit of that with my second use case
Maybe
later.
you could explain why it can't just respond if there's none, and then Amazon then let you know.
Well, so first of all, the only thing right for this app that's running on Amazon is the Lambda, and that's only triggered when I actually talk to the Echo. So if I wanted to tell me some other time, when I haven't talked to it in a while, that there's a problem, send me an email or whatever, text message. That needs to be something that runs regularly. There's absolutely no reason why that Python program that I wrote couldn't do that and say, oh, this is less than 25%, let me send off an email. But that would mean writing more sophisticated Python stuff and like going to the Raspberry Pi and like manipulating it on there. I'm actually just contemplating, you can actually remote desktop to this, or SSH into it. I might SSH you, we could do that. Is that interesting to you, or would you rather see my other use case? Let me ask that, we'll fork, and then we can come back if we have time.
What's your other use case?
My other use case is, let me just do it. Let's do that, and we'll come back. All right, and we can look at more detail here, but was there more to be mined here? Let's see. We saw the Python code. Did we see it? Was there any more we wanted to see in the Java code? I don't really think that the main thing is just that we went and got the values. So let's do that real quick, and then we'll move on. So I get a sensor reading now. So all it's going to do is get the feed info. So let me talk briefly about MQTT. So there's a queuing technology called MQTT, which is very commonly used with IoT. And the reason why is it's pretty simple to implement a client, either publish or retrieve data. And so even really lightweight microcontrollers can interact with it with relative ease. It's also a really compact protocol. So it's well suited to IoT problems. I didn't particularly need it in this case because I'm on demand saying, give me this latest value. So when I publish the messages to Adafruit, they actually are, I don't know, I think I'm using the REST endpoint there as well. So you can publish to a REST endpoint, and then you can retrieve from a REST endpoint, because I really only care about the latest value. But behind the scenes, they may be using an MQTT queue behind their REST API. And you have a lot more flexibility if you want to trigger behavior based on queues, because people can subscribe to those queues. So this particular use case didn't require that. The other one that I'm showing you does, potentially. So we'll talk about that a little bit more. So all this is doing is hitting a REST endpoint that has my latest value for each of those feeds. I just have to from the echo, figure out which feed it is, go and get that value, and then speak it back. So I have a tell response. So tell means she's not going to ask me a question, she's just telling me an answer. And she'll change, the tone and how she says it, right? If she's asking a question or, actually, let me mention that too. There's a metadata that you can put in your text that, what is it, SSNL, is that what it's called? SSNL? So if she's having trouble saying something a certain way, then you can give hints with these SSNL tags that will help her pronounce them correctly or add pauses in the right places so that it sounds a little bit more natural. I haven't messed with that because I'm the only user, and most of the time she sounds pretty good. So I haven't had to mess with it very much. But I did build some support for it in my utilities. So my tell response, my new tell response and ask response utility method will take text with the SSML tags and then render the content correctly. So here's the list sensors response. The available sensors are water temperature, water level. That's just hard-coded text that I just had her say back to us when I asked for the list of sensors. I could do something fancier if I had some sort of an array with those things, but that wasn't necessary for this use case. And then there's help, which in this case isn't very sophisticated. She just gives you some examples of things that you can ask her. So that's it for this code. So let's move on. Any questions before we do that?
Well, then, why did you, on that initial, on your launch intent, when you had the reprompt that said, here are all the options?
Yeah.
Why did you choose to close the session after that instead of maintaining an open session?
That's a really good question. I have no idea. Was it on launch? Did I close it? I mean, I must have if you saw it.
Yeah.
Where were you seeing that?
It was when you walked through the initial demo, when it listed out all of the options. And in fact, maybe it just didn't hear you with your response. Maybe that's what it was.
Oh, okay.
But it shut down immediately after.
Yeah, no, I didn't remember telling it to close the session on anything. But so I think it probably was an issue of not hearing me. Or maybe that interference again.
Sure.
Yeah. All right. UFO LED control is the other use case. So, anybody in Portland? Anybody been to the Nickel Arcade in Portland?
I want to hear her talk.
What's that?
I want to hear her talk, actually.
Yeah. Oh, the echo?
Yeah.
Yeah, we'll do some more here in a minute. Actually, well, yeah. Yeah, you paid to hear her talk, not me, right? So the Nickel Arcade, you pay a small entry fee. I have kids, right? So small entry fee, and then you go in, and then you buy a bag of nickels, and then there's a bunch of arcade machines, and they cost a nickel. And then some of them you can win tickets, and then they weigh your tickets, and then you can get prizes with your tickets, right? So my daughter, she decided that she wanted this UFO. So this little guy here. When you turn it on, it has this LED. She's been putting it in her bed, so it's kind of getting broken a little bit. But anyway, so this LED changes colors. And if it were a little darker, you'd see that it comes out the end of the fiber optic lines here. And of course, the first thing that I thought when she brought this home and turned it on and I saw it is like, wow, wouldn't that be really cool to put it on the internet and then have the echo change the color when I tell it what I want, right? And I actually had a microcontroller that I thought might be small enough to go in there that was Wi-Fi capable. So I asked her if she was okay if I did that to her UFO, and she's like, sure. So I tried, and haven't quite got it yet, but I'm not giving up yet. So I'll show you where I'm at. And this is pre-alpha. It doesn't even work yet, but I'm going to show you the work in progress, just because you might learn from my mistakes. And that's what I have to show. So anyway, that's the UFO. And so this is an Adafruit Huzzah breakout board on a battery pack. So battery pack, and then there's my little prototyping thing underneath it just to hold it, and then the board itself, which is about the size of 2 postage stamps, and it's Wi-Fi enabled, and it costs $10. And it has an LED on it, changes lots of colors. So that's the easy part. The hard part is to get it to work with this. And that's the part that doesn't work yet, but I'm getting there, and we'll look at it. And this little guy here is a NeoPixel. I don't know if you've ever seen some of these crazy videos with people who do Christmas lights on the side of their house, and they're like synchronized with the music, and then they do all of these little flashy effects where they go back and forth and they change colors and all of that. And there's a number of different technologies for these things. Adafruit's version they call NeoPixels, and I forget what the number is. It's like a WS2182B or something like that is what the kind of the common name is for that particular type of device. So what it is it's an RGB LED and a little microcontroller on it, on one board. And you can buy them in strips. And they're relatively inexpensive. And you have to power and ground the strips. And then there's a data line in the middle. So you only have to connect 3 lines. And the data line has this clock signal that it sends with pulses and with the signals that these guys interpret because of the order that they occur on the protocol and on the strip that they're connected to. So you're basically saying, turn the first one on to this color and this brightness and so on, right? And then turn the second one on to this color and this brightness. And they provide a library, and actually there's another library called Fast LED that some other folks have worked on that supports a number of the different technologies. Like there's another variant that has 4 leads. So there's a clock lead, which is separate from the data lead. And they're much faster, fast enough that you could do like POV effects and like video. If you had enough of them, you could do video and not have it be like super annoying flashy. The NeoPixels aren't quite fast enough for that.
What's the instruction set?
Well,
What's the processor?
It doesn't really matter. So, like, all you have to do is use the library to send the message, and how it actually works behind the scenes is an implementation detail that, to my level, isn't of interest. But if you're interested, I'm sure there's lots of.
The JVM's over on this side, right?
Oh yeah. So I mean,
Wi-Fi.
well, right. So and I should clarify, this isn't going to run Java. This is an Arduino compatible device, and Arduinos are programmed. It's essentially C++, but you don't really see it that way. The libraries are written so that they're pretty simple to use, and basically you have 2 methods that you implement. You have a setup and you have a loop. When you turn the thing on, then setup runs, and then loop just runs over and over and over again forever. And the libraries that are written for Arduinos and Arduino compatible devices usually have fairly simple APIs, so that if you know Java, then you pretty much know enough of a C-type language to be able to program an Arduino. I mean, and even kids are programming them, so it's not super difficult. And so you'll just use the Fast LED or the NeoPixel library, and you just tell it what color and so on. So the interesting, I don't know if think about it for a second. I'll see if anybody can come up with it. So I want to control this from the echo, and assuming that I can get the data to this thing for what color I want it to go. What's maybe the trick in there? What's the hard part about getting the echo to turn this to a certain color? Think about it for a second.
Define colors.
What's that?
Define colors?
Yeah. What is the color? Oh yeah, here's my existing installation. You've already seen it. Cheap plastic fiber optic LED UFO from the Nickel Arcade. So here's the architecture. No, I left out a pretty important one. This is one of the last things that I did. I'm going to skip that one and come back. No, actually, I don't have anything. I don't have it in there. I completely ignored it. There's an API I found called Color Lovers. And there are people who have identified color names and then put in RGB or HSV values into this database. And they provide this free API for non-commercial use. And you don't even need to have like any credentials to hit it. So I wanted to find out, well, what is chartreuse? Well, they can tell me what chartreuse is because all I need to do is hit their API and they can tell me, right? So let's find out. So, well, here's periwinkle, right? So I hit periwinkle, and the thing is I don't even know how it works because, let me zoom in again. So you see at the top, I say format JSON because the default's XML. The number of results 1 because if there's 10 results, I'm not going to have the echo ask you which one do you want. I'm just going to take the one that's the most popular or whatever. They have some different sort options, but I think the default sort was reasonable enough for me. It has the most votes or something, right? And then I can say keyword exact, which means it has to match. Because if there's not a match, I don't want it to pick something close. I want the echo can tell me, hey, I couldn't find a match for periwinkle, right? So then periwinkle doesn't show up anywhere in here, which I found kind of curious. When I went to the web page, I guess they have tags as well. And so one of the tags was periwinkle. You can actually, I'll show you since you have a link.
You gotta convert to like 32-bit or something, because you're back at 8-bit. 8-bit colors.
So here's it says dust in the wind, and then somewhere I saw periwinkle on the page, tags or something. I don't remember. But anybody have another color they want to pick?
Cyan.
What is it?
Cyan.
Oh, yeah, cyan, like that. Is that how you say it? Do you say cyan?
Cyan.
Cyan.
C-Y-A-N.
Yeah. So that's this one, right? Other one I know is goldenrod.
Eggshell.
Eggshell, that's a good one. So don't eat the snow. That's the title of that one. Yeah, it's probably a fair eggshell approximation, right? So now we have an API that we can hit to find out what the values are. And as it turns out, you can do either RGB values, which are fairly normal. It turns out that HSV are easier because you identify the color and the tone with the hue and the saturation, and the value is how bright it is, which is a lot easier for doing fading effects. So if you want, because what I wanted to do was I wanted to be able to say, set the UFO to cyan, or tell the UFO to flash, wherever or pulse, which would be like. Okay, so I suppose we should try. He says he wants to hear it. He wants to hear it work, right? So Alexa, tell the UFO to set the color to periwinkle.
Setting UFO color to winkle.
Oh, interesting. Actually didn't expect that to work. Because I thought that's where the bug was. Let me try another one. Alexa, tell the UFO to set, Alexa, tell the UFO to set the color to goldenrod.
I can't find the answer to the question I heard.
Alexa, tell the UFO to set the color to goldenrod.
Sorry, I can't find the answer to the question I
I'm in
heard.
trouble. Alexa, tell UFO to set the color to goldenrod.
Setting UFO color to red.
Yeah, that's what I expected. Almost every single time it says red. So this is a bug that I haven't figured out. And the reason why is this, is that the previous app, I had a constrained set of things that I could tell it, right? I had 8 sensors, and all I wanted to know was what that one of those 8 sensor values is. In this one, it's not infinite, but there's something like 13,000, I think, colors in their database, so it could be any one of those. And so this is a question that I probably have for you guys, is it seems like there was a feature that would allow you to have one of those, oh shoot, I forget the name again.
Custom slot.
Slot, that would be any value. But they seem to recommend not using that feature. So is there another way to do what I'm trying to do?
Automatically, no. So with custom slots, remember the uterances that you saw, or the variation of the same sentence? There is a parameter that you can put in a sentence. We call that a slot. We do provide a couple of types for slots, like USCTs, date time, and other predefined value. There is also a type called custom slots, where you can provide a list of all possible values that you expect. We used to have, but we are currently deprecating a literal slot that roughly allows to put any scenes, but the speech recognition on that web is not that accurate, and customer experience is not the best we can have. So that's why we are deciding to remove that literal custom slot.
Well, that's a real shame because it makes this a really difficult app to write.
So
on the other hand, I can
workaround
back up.
right now.
What's that?
Yeah, the workaround right now is to try to generate a long list of all possible value.
I'm not very excited about that, but I understand. But my evidence to support what you're saying, though, is that was the first time I heard it not say red. Was it came up with Winkle, which I don't even know what color that is. So, I don't know.
It's worth noting that when you create a custom slot, that's not an enumerated type.
Right.
It will fall back if it doesn't match something in that list to what's called the background language model or whatever.
Yeah.
So theoretically, you could define a subset that you define as like the most important set of values for that slot, and then anything outside of that, it should fall back to something else that you find within the lexicon of Alexa.
Well, and I assumed that colors were fairly well known, English language components.
It's
So
pretty easy to get the list of
well, not just that. What I meant is that even without my providing it, I thought that the Echo would be able to figure it out. Not that it knows that it's a color, because there's really not. I mean, I guess I could say set the color to, and if it's smart enough to know, there's context, syntactically of color, so I can constrain this to, periwinkle, I know is a color, winkle, I don't know what the heck that is. So, I don't know. I mean, I was making assumptions because I don't really know how it works behind the scenes, right? Because what I see is it comes up with the intent and what text it evaluated. I don't know how it got to that particular evaluation of the text. It might not match what I actually said. We found dildos on our shopping list. We asked my daughter, what was you ordering? She said, Jozos. She doesn't know, of course, what she really ordered, but Jozos.
Will limit your, where you have your sample utterances defined? Because I'm guessing what you did is you made a literal.
Oh, I did. I intentionally put a literal.
And did you put, for your example?
Yes, because it requires it. It didn't use, I think, am I correct in saying an older version didn't require you to put your default?
For literal, you always had to have the default.
Okay, you always did.
But
yes, red is the default, yes.
Yeah, that's the reason it's falling back to red.
Yeah, and that makes sense.
Whereas if you had just defined a custom slot that didn't have that many examples, it's a lot more likely that it would have gone to, it would have matched whatever other word.
Well, no, I absolutely believed that if I gave it a selection of options, that it would work. The thing for me, I thought the cool part was the color API integration. Like that was kind of the whole point for me, is that I didn't have to manage that. Like that was the clever part.
Is there a way where you can make that list dynamic? So like you could say, make this list not a text file, but go out to this API and get something back.
Not as of today.
See, the reason why you can't is because yeah, exactly. Well, that's the one they're deprecating, right?
Oh.
But the reason why you can't is that by the time it comes into my Lambda, they've already done the interpretation. So they can't give you some like non-interpreted version of what it was they heard. It would have to be the WAV file, right? And then you'd have to do all the hard work.
We're also looking into that.
I don't want to mess with the WAV file. But I hear you. I think that I can understand why for some use cases you would want that.
So what is debugging an application, speech application? Like, what is that experience?
Well, actually, that's a really good question. So let's look at the CloudBox logs.
Where do you get the voice recognition? Are you borrowing it from?
Oh, I don't do any voice recognition.
That's what the Alexa voice service is doing. So the Echo device is speaking to Alexa voice service, which is the web service on our side. We do the voice recognition and we translate that in a JSON file, and then we send to his web service wherever it is on the AWS cloud or on premises. We send a JSON text file. So for you as a developer, it's just receiving a text file, a JSON text file, answering with another JSON text file, and that's it. All the magic happens on the Amazon side.
Is that open source?
The voice recognition service from us.
That's where the money is. So here you can see it setting the UFO color to Winkle. So now this is my log output, right? This is not what I heard. So I don't remember if it actually has the full text of what it heard.
So to answer your question about debugging, it depends where your backend is running. If your backend is running on AWS as a Lambda function, you have to debug the Lambda function. If you have your own backend implemented as, I don't know, a Ruby or PHP application on premises, and it's your regular PHP repeat.
And I guess what I'm asking is like, can you set breakpoints? Can you can you evaluate code on the backend side while you're staying in assurance or something like that?
Sure. It
Like all
depends
that?
on your backend.
Yeah.
Your backend will just receive from us a JSON text file.
Oh.
So
okay.
any type of backend, anything
So
which
that's
is
outside
HTTP
of-
connected can actually handle an order, an intent coming from the echo.
Yeah, you can mock up your own data. You can say, if it provides me this, then how would I handle that? And maybe so you're testing, you can write tests for that pretty easily. I haven't messed with it enough. For one reason is because I was just getting familiar with what are the kinds of things that the echo could provide. Like, what are the possible ways it could interpret it and maybe fail in some cases.
So in the developer console, we have also a very simple text simulator. You can type your what you would normally speak to Alexa, and it will transform that into JSONs, call your backend, and you see the answer from your backend as well. So that's an easy way to test your.
Yeah, so sorry, I'm going to get up on my stump for a second because the question you asked for me and the guy I've been working with has been bar none the biggest issue that we face is the voice side of it. Like there are really good tools for testing the skill implementation on the back side of the voice, but there's no way to do automated testing of the front end of the voice interface. So we've been like talking to the chief evangelist about this exact thing over and over for the last several months. To the extent where we're considering writing our own tools to do this. Because the way people do it right now is literally to attach a microphone to the outside of their physical device and run audio through that. Like you just can't, there isn't a way at this point to do automated testing of the voice interface, which is the problem that you're having here of trying to figure out like what these audio clips or what a spoken utterance would resolve to. So yeah, that's one huge limitation that we found.
So in this example, would he be able to create an exception when she says setting the color to red, where that's not set to the user, and it says this color is not recognized, or this is invalid?
Yeah, I mean, that acceptance stuff you could definitely do, and there are ways on how you do that in a way that's meaningful for the user. So, because obviously you don't want to have the echo speak out of set to stack trace, that would be terrible. But in terms of testing that stuff, yeah, there are good utilities for that.
But it would not say set
If it were a Microsoft app,
it seems that it probably understood that he had to set a parameter. He had to set an exception saying this response is invalid.
Yeah, but the question is, how would you would never know that it was the wrong.
That's my question.
Yeah.
Well, I mean, I could make the default some like nonsense word, right? That's not a color, but I wouldn't know what was actually said. I would only get the nonsense word.
But wait a minute.
Right?
One test. You tell me you can't put a speaker, and basically a tube over the echo and hit it with a recorded.
That's what people are doing, but it's just that's a huge barrier.
And check what you get back.
Yeah, it's very slow.
Imagine if you could just have a bunch of waves that you just dump it. Like that's no way to automatically test something.
Yeah, that's what we've been asking for is the
yeah, just dump waves.
send the wave file.
So there is something that goes close to that. The Alexa voice service, which the Echo is talking to, is actually a web API. So you can directly capture sound from anything you want and send that to Alexa voice service for speak recognition in the cloud. So you're not obliged to use the Echo device. I have a phone app here that can talk to the very same Alexa voice service.
What formats does it take? Is there some proprietary format or?
I didn't look at the detail of that API, more on the skill part. Do you know?
It's not a proprietary format. It's
regular sound file.
Yeah, it's basically a wave string.
Okay.
So you can automate. The thing is, you don't. That's the way that you're doing essentially full end-to-end testing. You're not testing the voice interface itself because the output of that doesn't give you like what the actual resolved intents slots were. There are, and that's what we're thinking about building. Actually, is using AWS to tie that front end request to something that's listening on the back end, and so we can tie the two together and figure out exactly what a given audio clip resolved to behind the scenes. It's just a kind of roundabout way to do it.
It's cool. I've done a lot of stuff with like digital imagery and recognition. This is another scale of, right? To the power of, in terms of the fact that we're resolving down to typically bitonal stuff. You've got range of tones?
Our thing is we just want them to solve it, we don't want to solve it.
Yeah, right. So Sebastian mentioned that you can type in what your command would be. And I did use that a little bit because even if I couldn't get the part from the echo to my Lambda to work, I could directly feed information to the Lambda that it would then interpret. So I could actually do goldenrod or periwinkle or something and see it come through correctly. And that would allow me to test the whole rest of my stack. So, what I was wanting to do at the point that it came into the Lambda is, once I figure out what my action is, so turn it on to a color or pulse or blink or flash or whatever. So I have an action and I have a color name, which I would maybe want to put in here in the card. So I wanted to have the color name, and then I needed the HSV value. So those were the 5 things that I wanted to get in my Lambda. And then, well, I guess I would only get the color, and then I have to call the color API to get the others. But then I would need to publish them somewhere, and then get those communicated to the device. So let's get back to the architecture. Real quick, I wanted to show you though that it did find these values, the hue, saturation, and value, and the name Winkle. And from my Lambda, I just did sysout, and this is what showed up in the logs. In CloudWatch, and this was set up automatically. I didn't have to do any extra work, I don't think, to get CloudWatch logs for my Lambda. I don't know if there's anything we need to see here. Let me look real quick. This is the Lambda dashboard. So I uploaded a zip. So when I wrote my Java code, I just zipped it up. But you have to make it as an Uber jar. So use the Maven shape plugin. There's an Alexa skills kit dependency that you add, and also some AWS events. I can look at the problem if people really want to know, but I'm going to kind of skip that because those are easy things to get from an example. You have to configure it with a role, which is the security model that AWS uses. So you have to say which features of AWS does this Lambda have access to. So I'm going to show you that CloudWatch log over here because I suspect that might be what's going on here is I have a forbidden. When I tried to publish these values to AWS's IoT feature, I got this error. So I suspect my role just isn't configured correctly, but I ran out of time to debug it because I was only just doing this the other night when I was working on the slides. You give it the I think it has the method name too. No, it just has a class name for the handler. Event sources. So where will this Lambda be triggered by? It's going to be triggered by the Alexa skills kit. So this is how you tie them together so that the skills kit knows about the Lambda and the Lambda knows about the skills kit. There's some details in that I'm not going to go into now, but I can see how many invocations that there were. So these are all things about the UFO Lambda, and then the other Lambda also has its own stuff that we didn't look at. IoT, I'll touch on this real quick. So this is AWS's support for MQTT, and as I mentioned earlier, it's way more sophisticated than what Adafruit provides. You can use a sort of a SQL syntax to have rules that operate on messages that come in. Let me real quick jump over here. I threw this together pretty quickly, so I would not vouch for its utter accuracy, but it might get the basic idea across. There's an idea in IoT, or at least in more sophisticated implementations of it, of a device shadow. It's not just AWS IoT, right? Is that a general concept?
I don't know actually. It's part of AWS IoT.
Right.
I don't know any other IoT implementation like Adafruit or the others. I don't know.
Okay. Okay. So the idea of a shadow is that because your devices can come and go, you want a way to identify when the device comes back online. What state do you think it should be in? And so the IoT support allows you, even if this device is offline, I can talk to the Echo and have the state that I want it to be in captured in this device shadow. And then when this thing comes back online, then it will go and retrieve its shadow, and it'll continue doing whatever it was intended to do before. And so the sequence here, you can go to AWS and download a bunch of icons if you want to make fancy charts like they do. So if I've used the correct ones here, oh shoot, and I forgot to look at the terminology to remind myself. There's the intended, what you intend the shadow to be, what is it desired. So this is the desired values for the shadow. So I'm saying I want the shadow to be this, right? I want the values for HSV and the color name and the action to be these 5 things. So my Lambda with the echo has to send the desired value over to the shadow. This is the shadow. And then when the shadow changes, then that gets put on this queue that the device subscribes to. And it's notified, hey, you're supposed to change your value in order to match the shadow. And so then the device then changes the LED value and then publishes back, I changed to the desired value. So I'm basically acknowledging that I did what you intended of me. And so then the shadow knows that it's been confirmed, because the shadow keeps track of whether it's actually been confirmed or not. So that's a basic idea of how you interact with it. So the use case-wise, the reason why I chose these 2 use cases for this topic, or for this session, is the other one, that was passive. I just wanted this thing to go out and find a value that was already there. I didn't have to change anything based on it. It's the local interaction that's the point. In this case, I'm actually using the echo to initiate something. And so it's changing a status on something elsewhere. And for me, I'm kind of wanting to play around with some of these ideas. I wanted to have 2 different kinds of use cases. So these are the first 2 that I've done personally. And I'm learning a lot, so I think they were good use cases for me. So one thing I'll mention with this is these devices are fairly easy to program, but you always run into little gotchas sometimes, and I've had this one lately that's been driving me nuts, and I blew several hours on it this week, which is I just could not get the Arduino IDE to recognize my serial port or my USB connection to this thing so that I could upload new code. So I felt like maybe I could have had this thing working, but you have to leave enough time to figure those things out, because every time I've ever tried to do Arduino programming, I run into some level of that. So just account for it. For whatever reason, it's always harder to get the code on there than you think it ought to be, and you're supposed to just be able to click it, but it never quite has worked that way for me. I'm going to go over a little bit of the details on some of these microcontrollers, just because I wouldn't want you to invest your money in the wrong things if you want to do some of the things I've been talking about. So I'm kind of winding down, and I want to leave some time for Q&A. So this is, as I mentioned, a Huzzah breakout board. Now the Huzzah is really cool and really cheap, but it can't work with the Amazon IoT support. And the reason is because it isn't able to do TLS 1.2, which is a requirement. So if you want to do that, I'm going to move this guy out of the way. If you want to do Amazon, you're going to need a more powerful device. So that's the Huzzah. This one here is a little more powerful, and it is the Feather Wicked, they call it, W-I-C-E-D. And this one has a little 4-line LED on it, and this one I was having even more trouble getting connected. So unfortunately, I've never even seen the LED work. I just ordered these a little while ago, but they stack. So this is a whole 4-line LED OLED, so it uses very little power, and it just stacks on top. The Feather system is a Adafruit invention where they have all these little microcontrollers and accessories that stack or that are built to work together. I'm sorry it's so dark here. But this is a much more powerful device, much faster, and it will work with the AWS IoT. So I'm really hoping to see that work. If anybody has worked with these successfully on a Mac, I'd love to hear from you. And then they sell these little boards here that just let you slide your Feather on it and then screw into the various different leads, just because it's easier to work with. You can see on the Raspberry Pi, I kind of did that myself by putting in these little screw mounts, or screw connectors. But I think that the pins are actually bigger than is really intended for those, so I probably damaged my prototyping board doing that. But I was committed to this project, so. So there's more GPIO. You can actually get the Huzzah in the Feather form factor as well, which lets it stack with the ILDED and all the others, but it's still not powerful enough to do the AWS IoT. So, you know, $10 or 35, go with the 35, it's probably worth it, because you probably want to use the AWS IoT at some point. The other thing is that this one plugs right into your USB, and you need this special FTDI cord, which plugs into your USB port, and then plugs on top of these pins. I can't see now. You can come up and look later. But you can reuse the FTDI for all the other Huzzahs that you buy, so you'll get your money's worth out of it. And this board is pretty compact. But I think for the future I'd probably just go with the fancier one. The other thing is it has the battery charger built in. So I'll show you. Anybody who wants to come up, I've got a bunch of microcontrollers afterwards. You can come up and look at a selection of them. And they have a LiPo battery, which is a lithium battery that plugs in. And so these little feathers, they have a battery connector on the side. And you plug it into your USB and it'll charge your battery. And then it'll stop charging when it's full. And then you can take it off and it'll continue to just function. And all of the microcontrollers in that Feather form factor have the battery charger built in. So if you're going to commit to that whole ecosystem, like there's a lot of value because you can just replace all of the items. Raspberry Pi versus the Feather. So it's worth noting that these are pretty powerful little single-threaded devices. Like you don't have access to nearly as many capabilities as you have on the full Raspberry Pi. And remember, they're the same price, right? A Pi is $35, this guy's $35. They're both good deals, but they do very different things. This thing is a much more powerful computer. The Raspberry Pi, it's a full PC. You can browse the web on it. You're never going to browse the web on this guy. You're going to power a little 4-line OLED, right? But this thing can do the timing requirements for some of those, some of the sensors that you're going to want to use or the lights that you're going to want to control. They need more precise timing, which this thing can do as long as you don't put delays in your loop. But the Raspberry Pi, because it has interrupts in your operating system, and so something's going to take over for a while, and it's going to take your CPU cycles, and it's going to mess with some of the things you want to do. So for timing critical type things, this is the one you're going to want to use. For general purpose, cheap PC, the Raspberry Pi is totally fine. You're not going to SSH into this guy either. It's just an Arduino with Wi-Fi and some other fanciness. Well, we already did the UFO demo. That was way out of order. And we did the quick walkthrough. There's not a lot to see there. I'd rather spend time on Q&A, but if anybody wants to see it, they can. So here's some references. I'm going to turn this into a PDF and have Nimrod post that for anyone who wants to see it. But I've got Adafruit on there, DxSol, the Chinese company, AWS IoT, and Nickel Arcade, in case you need to buy your own. You have to win it. So good luck. You can win your own plastic UFO. Adafruit Feathers and NeoPixels, they have little subsites there at Adafruit where they tell you a lot about how to use them. Links to their libraries that they use for the various features, like accessing the Wi-Fi or controlling the NeoPixels. And then the Color Lovers API, because I still thought that was pretty clever. So, any questions?
You didn't put up the references for the Raspberry Pi.
You know, I didn't put the Raspberry Pi on there. You can get
Element 14 and MCM for the two.
Yeah, well, I mean, you can get them on Amazon. That's where I bought mine. So, but yeah, Element 14, I've bought some stuff from them before as well. They have some good things.
There's a question on the Echo. So most of those use cases are about me talking to it to initiate.
Yeah.
Is there any thought in the future to have it could be very annoying, but having it actually be subscribed to a push notification and alert me to something?
I'm looking your
That's
way.
a very frequent customer request.
I can imagine it is.
The use case would be I order my Uber, and when the car arrives, the device prompts me saying, "Hey, your car is there."
Yeah.
So,
I mean, the super basic model right now is
stay
set an alarm for
And
me.
the problem is to find the balance between privacy or not privacy, the interruption.
The distraction,
the distraction and the utility of the feature. Stay tuned.
Okay.
So the Echo can't do alerts right now?
Sorry. One at a time.
So can the Echo do alerts right now? You can't have it say, alert when something happens?
So there is a built-in feature which is a timer, which I'm using a lot when cooking. Say Alexa timer in 20 minutes, and it prompts up songs after 20 minutes. But there is no API for you to provide a notification to your end user yet.
Okay. Yeah, I was thinking like something like a smoke alarm detection.
No, that couldn't work today with the existing API as it is today. Stay tuned.
I totally understand the ask, but I could also understand why they would never choose to implement it.
Yeah.
Because it would be just too disruptive and unexpected.
How many notifications do you get on your phone today?
Well, it's not only that,
these ones are making sounds.
I think we fundamentally expect something different from something that talks to us.
Yeah.
Like, we don't expect to be interrupted by something that talks to us. We expect to be interrupted by our phone because it's a pretty dumb device and it's just going to buzz. It's not insisting that you listen. But when you're having a conversation at your table and then Alexa speaks up, it's kind of funny now, like, but maybe in a year, like, it's going to be like, why is she doing that again? You know, like, maybe it's, I don't know, but I mean, obviously we're anthropomorphizing it, right? And so that means we have certain expectations for how it's going to interact with us socially.
I think beyond that, there are also privacy concerns. Obviously, as an employee, you can't make claims, but the running theory in the dev community is that this will never be implemented just because there's already so much hair pulling around having this device that's listening to you all the time. That's why there's like a visual indication. Like if I say Alexa across the room is going to turn blue, you always know when it's on and listening. If you have it muted, it turns red. So this idea that it could just wake up and do something on its own, I think would be, from a customer standpoint, a lot of people who don't understand the technology behind it would have a really hard time with that.
Do you think you trust that it doesn't listen when it's on blue?
Well, that's
No, I get alerts here and I can say, hey Siri. So.
It's not just you have to say Alexa, or there's other things you can swap in place of that to make it.
Right.
You have to trigger the listening part of the hardware. So right now it's listening for the keyword, but it's not sending anything to the AWS cloud for voice recognition.
Yeah.
If I say Alexa, okay, Alexa, now it's listening and actually sending what is listening to the cloud.
Yeah, it's worth pointing out that the Alexa voice service, the other thing that you mentioned earlier, where people can do their own integrations with Alexa. If you are going to publish something that uses that, you are not allowed to do far-field voice recognition. It has to be push button, like the tap here, where you press the thing that actually starts it up. So if you had a phone app, you couldn't have that listening. I mean, you can maybe do that for your own personal projects, but that's not something that they would allow you to certify. They've been very clear about that up to this point.
What's the tap? What's that?
It's a Bluetooth speaker that's Alexa enabled. It came out a couple months ago.
Wireless.
Yeah, obviously there's
battery powered.
No cords here, it's battery powered. I mean, it is literally like a Jambox or any other Bluetooth speaker, except that it has this button that you can use to do the same stuff that he's doing with the Echo.
So like to activate it, you have to press the button.
Yeah.
You cannot just say Alexa. It's not listening all the time. You have to press the button. Which removes a lot of uses when you are cooking.
Yeah. That's the biggest thing
You
that I
don't want
like
to
about
move to the things, press the button to talk to it. That's one of the big advantages of the Echo. It's anywhere in the room or across rooms, you can talk to it or to her, which is the answer.
That's designed for it.
Yeah.
Yes, so your Java app that you wrote to give the temperature water readings,
Yeah.
you deployed that onto the AWS Lambda service?
Right, so I had to build it as a zip, and then I had the Maven Shade plugin configured.
So how did that Echo device get authorized?
Yeah, that's a good question. So you have to go in and create an Alexa app. And then it's on my developer account. So I think it's tied through when you're developing an app. So I've never released this, right? If I wanted to release this, I has to go through a process where they approve it. I've never done that. I just leave it in test mode, and it's tied to my account. Well, it's the same account that my Echo is tied to. So I don't remember having to do very much. Maybe I had to put a thing in my Alexa app.
Yeah, you go to the developer portal for Alexa, You enter a lot of meta information about your app, your skill, like the uterance, all the sentences that you saw, the custom slots we talked about, and you give the endpoint that the Alexa voice service needs to send the information to. So the Alexa voice service will receive the voice, transform that as a JSON. The only things you need to do is to give us where to send that JSON. It might be an HTTP service that you already have today on premises. It might be a Lambda function. It might be another HTTP web service running on AWS, running on Azure, running on, we don't care, HTTP or Lambda function.
Because I was thinking actually of corporate uses for this. There are executives, I think, who actually buy into this as a way to like check the status of something. So that's why I was kind of wondering, in a corporate environment, I'm never going to publish that to the world, but I just want, 3 or 5 of these devices to be logged into my app.
If it is 3 or 5, you can do that manually. So as long as you don't publish the app, it's available within your Amazon account. So if you have 3 or 4 different Amazon accounts, you can publish the same skills manually to 3 or 4 different Amazon accounts.
And how do I do that?
Through the developer portal. So you connect with, you have your name at, you have your email address to connect to Amazon today. You go to developer.amazon.com and you connect with that user ID. And that user ID will also be linked to your devices.
And I actually meant to show you guys this, but yeah, here's where you can do your configuration. So I didn't end up showing you everything I meant to. This is the list of intents, and then you have to declare the slots. Kind of moved on and forgot about it. And then you can have custom slot types. So I'm having trouble figuring out how to do this with this.
So this is declared here in addition to the code in in addition to your Java code?
Yeah, I had to put in the list of sensors that were available here so that that slot would know what to populate it with. And then that was the text that I used to look up which intent it was using. And then here's the actual intents that I pasted in from, there we go. This is what I pasted in from that text file that I showed you. So these are the 3 pieces of configuration that you have to put in when you declare it. And this is what the Echo uses to create the request that it will then call you with to do the interpretation of what possible things it can expect to do. But
on the next one, you see the endpoint.
Yeah.
To call. So this is a web service that we are going to call whenever you talk to the Echo device.
And I haven't used this account linking, but if you have some other service, web page that your users can go to that they already have an account on, and you can link that with Echo users so that then they're authenticated for your endpoint.
Yeah, typical use case for that is that you want to actually authenticate the user to make sure that it's one of your customers. We get access to his profile, maybe it's a credit card. Let's take a sample, an example, the Uber skill, the Uber application for Echo will require to go through account linking so that they can match your profile and your credit card when you order a Uber car with the Echo. And it's regular OAuth 2, so any OAuth 2 enabled backend will work with this.
So what are the implications around security or abuse, or like how you do for somebody to an application out there that doesn't various? Can you speak to that a little bit?
So as of today, when you link a user profile on a third-party service like Uber or Domino Pizza or this, the linking is made between your Amazon account, so your Echo, and your third-party profile. So as we said earlier today, we don't recognize a different person talking to the Echo. So anyone having access to your Echo can potentially use the service. That's what you said, that your friends are making jokes and ordering things from Amazon, or reordering things from Amazon when they are at your place. So disable, mute, unplug the Echo if you are inviting friends that you don't trust.
We can find out who your real friends are.
Depends what they put on your to-do list or trying.
Yeah, I was actually talking to someone the other day who has integrated their whole, all their smart home stuff with their Alexa, with basically an orchestration service. But the one thing they wouldn't integrate is disabling their security alarm. They can enable it, but they can't disable it. So that if somebody had broken into their house, they couldn't just say, Alexa, security off.
Yeah, I noticed you can't delete things from your to-do list using Alexa. Probably safety standards. any destructive action.
So just to show you how the test works, you can say, what is the water level here? And then ask crawl space. And it shows you what the Lambda request is that it would create, so that, or that it actually does create. So you can use that to mock up data that you want to publish against your.
And once again, Lambda is not required. It's a super easy and cost-effective way to implement your service.
Yeah, you can
But
do
if
it.
you have an existing web service running on premises, we are fine with that too. If it's on Microsoft Azure or Google, we are fine with that too.
Yeah. And then here's what its response was, is the crawl space's water depth is 29. So remember when I asked the water depth before and it didn't tell me? I don't know what that was. We can go look at it in the logs, but this time it did.
But where in that request that's past the WAV file, right?
Yes.
So, yeah. So this is, go ahead.
And also that's for testing. So this is an easy way for developer to test their implementation of the skills. You don't need to talk to the device, you just type the sentence, you can ask the name of your skill, and we generate for you the corresponding JSON file.
This is assuming perfect interpretation.
So, do you actually stay on that cell, reset? And it's like another.
No, I think that's just for this thing. Just clears the fields. Yeah. I do.
All right, cool. So I think Jesse's got a couple of sensors out there in case people want to hang around, and I think we're going to go for gears also. Thanks everyone for coming, and we're running really close to the time limit here, so we'll see you all next time. Thanks.
Great.
Good night.
And there's my contact.